Good morning. Boy, am I excited about this one. I'm going to be working on the seam carving puzzle on codinggame.com, and this is a really interesting one. And it's fun because this is actually we're going to be working on an algorithm that is used in the real world. Like I'm pretty sure Photoshop implements this algorithm. It's used to modify images when you want to shrink them or even enlarge them. It's an algorithm that will help you do that with minimal image distortion while keeping the important elements of the image in place. So here's an example of that. We can see here the original image. Boom. Castle, lots of nothingness, person looking at castle. If you want to scale it, this is what you'll get, right? If you just squeeze the image, you end up with like a really weird looking castle. If you crop it, well, if you do it by hand, you might be able to do something that's all right. But if you want some sort of algorithm to do it for you, you'll end up with something like this. And here's what seam carving does. Seam carving will remove the pixels from the image that are least important in a way that will keep the image, well, how should I say this? Well, it won't distort it. It'll remove it in a way that will make the image transition or different seamless. I guess that's why they're called seam. I don't know. So, how do we do that? Well, here's the puzzle description. Seam carving is a content-aware image resizing technique that often leads to impressive results despite being very simple. When used to reduce the size of an image, it intends to remove the supposedly least significant parts of the image instead of resizing everything in a uniform manner. In this problem, we implement the main algorithm behind seam carving. To focus on the algorithmic aspects, we only reduce the width of grayscale images. Okay. Given a grayscale image of size width by height, W by H, let I, X and Y, so that's a function, be the 1 byte intensity from 0 for black to 255 for white of the pixels at X, Y. Okay. And with X being bigger or equal to 0, of course, and also smaller than width. Yes, so 0 indexed array. Same with Y. We define the intensity differentials and the energy function as, here's a little bit of math. For those of you who are familiar with vector calculus and stuff, this would be the partial differential of our function here. This is our function, which depending on which position in the image, x, y position, we're going to get a number, an output from that function of 0 to 255. Now, if we want to know the intensity, the energy value, that's interesting because he changes it to E here. Anyways, okay, so they're basically gradients. We calculate the gradient at this position for X and for Y. So for those of you who aren't familiar with that, a gradient is basically the rate of change in a certain direction for a given coordinate in our case here. So at XY, here we're calculating in the X direction, right? By how much are we changing our value being the grayscale, 0 to 255. So we're taking this point and we're looking, if you see here, x plus 1, x minus 1, right? Y stays the same. We don't care about y. So we're just basically looking at the value from 0 to 255 to the left of us and to the right of us. And we're taking the one from to the right of us, of our given point here, and we minus that by the one to the left. And that way we know by how much, we know by how much the grayscale is changing in either the right or left direction. If we get a negative number, we'll know that it's actually increasing going left. And if it's a positive number, we'll know that it's increasing going right, and by how much. But that's only one part of the equation, right? Hey, Faint, what's up? Working on an interesting puzzle here. And we're doing the same with the Y. And we're taking the, what's this? Right. So I think we're basically getting, this is the magnitude of the gradient magnitude. That's what we're doing. So we're taking the absolute. So we don't care at this point here, we don't care whether it's positive or negative. We don't care in which direction it's changing. We only care that it is changing and by how much. So we're taking the absolute gradient for the X and for the Y. We're adding those together, and that will be the energy value for that particular pixel. We need to do that for the entire image. So for the entire image, we look at each single pixel. We look to the left, we look to the right, we look on top and bottom. Then we get a value for that pixel, move on to the next pixel. And we do that for the entire image. And then we end up with, what would you call that? I don't know, like like gradient magnitude map for the image. It's basically going to show us probably like the edges of the image. I just had the most stressful day ever yesterday. Bed bugs in my, oh man, that sucks. Bed bugs in your room. Spent the entire day cleaning it out. My room and drying my clothes. Man, I'm sorry. Yeah, that bites. That bites, get it? Okay. Okay, so once we're done with that, that's just one part of the algorithm. Once we're done with that, we then need to... A vertical path is a sequence of pixels. x0, 0, x1, 1. Okay, we're basically going down. That's what it's explaining here. That bites with a Y, yeah. So we're basically starting at the top of our image. We're going down, right? Going down the x-axis here. Wait, hold on. Shouldn't x be... Well, either way, it works in any direction. Because y would be the top, bottom one normally, wouldn't it? Vertical path, vertical. So vertical is up, down, but we're changing the x. Isn't x normally the left, right, the horizontal axis, and y the vertical axis? Either way, like I said, it works in both directions. But I'm pretty sure. Okay, so if he's saying vertical, however we choose to do this, so we go down from the top of the image. We go down such that xy plus 1 minus xi plus 1 minus xi. The absolute value of that is less than 1. Xi plus 1. In other words, the path contains exactly 1 pixel per line, and consecutive pixels are vertically or diagonally neighbors. Okay, I get it. Yeah, x1 plus 1. Okay. Christ, and I thought I could escape from calculus. Oh, no, that's what. When you do these puzzles, man, sometimes you, yep. It's not that complicated, though. So if you know a little bit of calculus, we're looking, basically, these are partial derivatives. They're gradients. We're calculating the gradients for each pixel and getting the magnitude. It's a fairly simple algorithm, I think, although there's many steps. Okay, so then that's a vertical path. The energy of a path is the sum of the energies of its pixels. Right, which we've calculated here. So each pixel has an energy. A path starts at somewhere at the top, ends at the bottom, and it's the sum of all those pixels' energies, okay? To reduce the width of the image by 1 pixel, compute a vertical path of lowest energy. Okay, and simply remove it. To reduce by several pixels, simply repeat that 1 pixel reduction step on the successive reduced versions of the image. Yep. Okay. So basically what we're doing is it's like a pathfinding thing, right? For each pixel at the top, we start at the left, and then we calculate the path of least resistance, basically. We look at the how are we going to do this? Oh, I think this explains it. Right. So we start here, actually, and we look at the 3 topmost ones. We add this. Yeah. And we do the same thing. Look at these, add it, and then we do the same thing as we get down, and then we end up with a number at the bottom. We just look at the bottom, and that way we know which one is the path with the least, what did they call it? The lowest energy. Path of lowest energy. Okay, instructions. Given a PGM image, PGM, what kind of format is that? PGM, anyways. See input description, okay. And its desired new width. Resize it using seam carving. So this is pretty cool because we're actually being given as an input an actual file, is what I understand here. Well, maybe not a file, but the, you know, the value of that file. Well, maybe. It depends on the file format. Anyways, when there are several paths of lowest energy, remove the lexicographically smallest one. I think it means the leftmost one. One over the exit values, i.e. the left. There you go. The leftmost path from top to bottom. Leftmost path from top to bottom. Oh. Okay, so that means looking at the top row, you take the leftmost path. That's annoying. Would have been easier to take the bottom one, I think. Whatever. Ah, no, doesn't really make a difference. Does it? Oh yeah, it does. Anyways, we'll figure it out. Due to the limitations of on the output size, you are not asked to return the resulting image, but the energies of the successively deleted paths. Oh, okay. Okay. So we're not actually returning the image. That's interesting. The modified image. Additional remarks. Try it on your own images. And this is what's really cool, because once we're done with this puzzle, I'm definitely going to take the algorithm and play with this in the real world. Maybe make some sort of library that can be used in the browser that helps you, resize your images. I don't know. Whatever, we'll see. Try it on your own images and visualize the results. You might have to relax your PGM parser as the specifications of the format do not actually make the space new line distinction for very large images, make sure that you use an efficient algorithm and optimize your code so that it keeps and updates the intermediate results after each path deletion. Oh, right, to avoid a review. But it seems like we might not need this for this puzzle. All right, I think we've got what we need to get started. I think. Let's look at the inputs. It's a PGM ASCII file. Okay. This is what it looks like. P2, what's that? Line 1. Contains the magic number P2. Okay, just indicating an ASCII grade map. We don't care about that. 2 space-separated integers, W and H, corresponding to the width and height of the image, 30 and 8. Okay. The pound character to start a comment, followed by a space and an integer V, indicating the target width. Okay, so this is, so it's always going to be a, okay, so we're not modifying it horizontally ever, so we don't need to implement that part of the algorithm, just vertically. And this is the line that tells us what they want us to reduce the file to. So in this instance, we have a width of 30. We want to go down to a width of 29. So we're just removing one seam, one path, and that's the output. That's the energy value of that path. So 175 at the bottom. This would be, you know, a path that ends here. No, that doesn't make sense. That's the actual, yeah, that has nothing to do with these numbers here. We'll see that in a second. Okay, line 4 always contains 255, indicating that the intensity is coded on 1 byte by an integer between 0 and 255. I wonder if we should get into using byte arrays and stuff like that. It would be more efficient. I don't know if I'm going to do that right off the bat. I'm not all that familiar with them, but it could be something to do to refactor if we want our algorithm to be more performant. Okay, and the next lines are actually our pixels, right, indicating the intensity is coded on 1 byte by an integer between 0 and 255. Yeah, that's the same. I looked it up like when I was deciding. So what? Hold on. I'm super hyped to try this puzzle myself. Thanks for streaming all these interesting sites. Yeah, yeah. When I decided last night what I was going to do, and this is the puzzle of the week on Coding Games, so I just looked it up, and I saw the description. I was like, man, this is so cool. Can't wait to do it. I was like coding in my sleep. You gotta go. Okay, take care, man. All right, so let's get started. Let us get started. This is just like the auto-generated code that they give us for the beginning of the exercise. Read line, oh yeah. So I gotta declare I'm using TypeScript. So as usual, I have to tell it about this readline function that Coding Game is using. So function, no, what am I doing? Yeah, function readline. I think that's how I'm supposed to do it. No, maybe not. String. Yep, looks like it's working. Yep. Okay. Now, should I try to do this test driven? Why not? Let's go with this. Describe. We're going to call this seam carving. Just seam carving. Just wrap up all our tests that we'll be doing in here. Describe, nope. Describe. Test. Okay, what's our first test? Well, let's think about this. Okay, let's just do the actual test case, the actual first test case that they want us to, which I think is just that this we're seeing here, height 8 and width 1. What do we have here? Height 8, height 8 and width 1. Oh, okay. Minus 1 means we're just taking 1 away. So let's just grab this as our input. Actually, we'll use the same wording for our test case name. Boom. There we go. And then this is going to be our input. No, okay, input equals this stuff here. There we go. Okay, how am I gonna format this? The easiest thing to do would be to use this. Boom. Ah. Oh, but I gotta make sure that it's completely to the left. There we go. Okay, so we've got our input. And what's our expected here? Expected is simply 175, I think, eh? 175, yep. So a string that says 175. So expect, okay, I gotta make my actual here. It's actual is going to be whatever. Am I going to make this a class? Am I going to make this just a function? I don't think there's a point in making it a class. We're just going to be, yeah, I don't think so. So we'll just make it a function that we're going to call, what are we going to call this thing? We're going to call it carve. Carve seam. Reduce width. Yeah, just because that's essentially what we're doing, right? Reduce width. Reduce image width. Seems like a good name. And then we pass in, oh, actually, if our input is the image file, and in this case it already has, this is through a comment. Yeah, let's make it, instead let's do it a class. We'll make it a class that will wrap our image file, and we'll have a method on that class to reduce image width. So we're going to do, okay, let's see, const image equals new, kind of what was the file format here? File format was PJM, new PJM image. Does that sound right? This should probably be like this, PJM image. And we're basically just feeding the input into that. Okay, and now our actual is going to be taking our image, then reduce image width. There we go. In the real world, it would make sense to make this function take in a parameter with the new width we want to have. Here, it's actually encoded in the image file as a comment. So that's something that we're going to have to modify if we port this to an actual application. But okay, so we're taking this. So expect actual to be, oh, right, that's not true because we're going to call this instead remove seam. Remove seam, because that's what we need. So we're going to remove the seam and return its energy value. Because that's what our puzzle wants. That's cool. Okay, we'll do that. So expect it to be expected to be. Is that the right one? To be checks that the value is what you expect. It uses triple strict equality. It checks strict equality. Yeah, to use. So yeah, that'll work with the string. That's good. Okay, so now don't even need to run the test because I know it's not going to work because we're already aware that we haven't implemented this. So let's start by doing that. Just going to do that right at the top. Class PGM image has, well, needs anyways, a constructor that takes, let's call it file here, of type wet. Well, I don't have a type for PGM image. Well, it's just going to be a string, really. Let's just call it a string. All right. We're going to be doing something in the constructor later, but I don't know what. Now we need a method called remove seam. Remove seam. And that method's going to be returning a string. Return string. Good, now we can run our test without any compilation errors. And our test fails because it's interesting. Hold on a second. PGM image, did I not, is not defined. Oh yeah, c'est moi. And I thought we wouldn't get any compilation errors, but we did, because I didn't export this. There we go. Let's run this again. Okay, now it's failing because readline is not defined. I'm not even using it in... Let's just forget about that for now. We don't care about that. We don't care about any of this, actually, for now. Okay. There we go. Okay. So it's failing because it should be receiving 175 and it's getting an empty string. Easy fix. Super easy fix. Watch me. 175. and boom, we passed our first test case. How's that, huh? Yep. Nope. Yes, passed. Okay. All right, so now what do we do? Well, we try another one. To force us to actually do some implementation instead of being silly and just returning the value that we know it wants. So let's take a look at our next test case, which is called height 11 with, oh, there we go. Like that. Nope, totally didn't work. Let's get in there. Okay, that worked. Good. Now our input is going to be, this here. Like that. Did I do this right? I did. And our expected output is 120. 120. So let's see if our remove seam method implementation will give us the right answer. I have my doubts. Yeah, there we go. We're receiving 175 instead of 120. What? How could I do this? Well, I need to implement my algorithm. Now, this is going to be, the remove seam function is going to be a kind of a all-encompassing function. I think maybe a facade is the right word for this. It's just going to basically call other methods that we're going to need to implement. But the first thing we need to do before any of this, before we can do anything with this, is parse our file when we construct our PGM image wrapper. Okay, so our input is coming in, and this is where, how am I gonna do this? Actually, here's what I'm gonna do. Instead of passing in the file, no, yeah, it just makes sense to have the file passed in. But here's what I'm going to do. I'm going to do a file parser, maybe. So what what I need to do, I actually need to, this is the parsing stuff here. And it's coming in one line at a time. So we can build our file, which is just a string, using this. I guess the reason I'm doing it this way is because I want this to be usable out in the real world. So let's do it that way. If we class or maybe just a helping function. Yeah, let's call this make file. Right, make file is going to taking our readline function. So, oh, I said I would do this TDD. So let's do a TDD. We're going to do this at the top here. Now, should I just X out these tests for now? Just going to focus on this test. And actually, we're not going to do that in here. Since it's a helper function, might be useful in another puzzle some other time. So for now, we're just going to put that here. Describe. What were we going to call this? We're going to call this make file, or maybe just make string, really. Make string from readline. I can probably just make it as just a one test. I don't think I'm going to need more than one test for this. Okay, so what's our input? Our input is, what are we feeding this thing? Well, we can take this. Let me think about this here. I need to simulate readline if I want to test this properly. Okay, so I need first to make, so const readline. Yep, read line. That's what I need to do. Const readline equals new my string, which is a little helper class that I've I think I called it my string. My string, yes, and I'm exporting it. My string. It's not seeing it. So let's try importing it here. My string from why did it put double quotes? I don't have a linter here, but we need to go back up to helpers and my string. There we go. String, my string, value any. Good. Now our value, our input here, we can actually, yeah, we can use all of this. Input, that, this works, and we make read line, and we pass in the input. What read line does basically, what my string basically does is it wraps a string, and it has this method that allows you to just, when you call it, it spits out one line from that string at a time. So it takes, you know, if you have new line characters in that string, and it basically simulates the read line function in code in game. So I'm giving it this input, and it's gonna, every time we call it, it's gonna spit this out, then it's gonna spit this out, then it's gonna spit this out. So, okay, and we know that works, so, because it's tested and everything. Now, what I'm actually trying to test is that we're making a helper function to take lines one at a time and reconstruct this here, which, so that's interesting. This is actually our expected. How's that? It's our input and it's our expected. So basically we're implementing the reverse of read line. Now I'm wondering if I shouldn't just make that a method, like a static method maybe on my string. Because we're essentially constructing a string, and we're doing that with no, I don't think I can generalize it like that. Maybe some idea will come to me, but okay. The thing is, how do I know? How do I know how many lines I have? So I can't really generalize it, because this stuff is coming in one at a time. So at any point here, I don't really know how many more of these I have. Oh, but I will be getting a null at some point, and this is when I get to stop. And just close the string. Boom. Say we're done. So it could look something, it could be like a while the string is not null. It would really screw things up though if we're trying to make a file that has a null on one line. What are the odds of that though? Well, if it's to be generalized. Okay, let's try to solve this puzzle here and not all of the world's problems. So we know this is what this looks like here. So how do we take our inputs here and let's take a look at what I was doing here. Remove seam, constructor file. I'm thinking of making, I need something to make that file. I need something to make that string. That's all that I need, really. So let's not go crazy here. Make string from read line. That. So we expect that actual is going to be expected. Now, what is actual? Actual is going to be our helper function thing that we're make string from read line, and we just pass in read line. There you go. Okay, that's what I wanted. Just pass in read line. There we go. Okay, this will work. Well, not yet. I have to implement it, but the test will work. So we're implementing this here. I'm just gonna put it here for now. Export function, make string from read line. You're going to be returning a string. Return, just so that it compiles and we can run our test. Port that. Yep. And what seems to be the problem here? Read line. Expect 0 arguments, so that won't compile if I do that. Read line is of type function. It's a function that doesn't take anything and returns a string. That's what we're expecting as a parameter. Okay, I think we're good. Maybe not. Dot read line. There we go. Now we are in business. Yep. Let's run the test. And it fails because we're supposed to get this nice file looking thing, and instead we are getting an empty string. So let's implement. What are we trying to do? We want, with this read line thing, to basically concatenate everything into a big string. Not too hard. Not too hard, I would think. So you just, whoa. You just go for, actually, let's make it a while loop. While read line let's put that here first. Let line, oops, that line equals, let's not initialize it first. Then while line or should I do a do while? Yeah, because I need, once I get to, let's see, do. What's the syntax with the do while again? I very rarely use it. MDN, do while. Creates a loop that executes a specified statement until until the test condition evaluates to false. The condition is evaluated after executing the statement, resulting in the specified statement executing at least once. Is that what we want here? Well, the first thing we need to do is in a loop, we need to read a line. So okay, let's just do this for now. We'll figure it out afterwards. So while true, how's that? First thing we do is we read line. And we put that here. Our line is equal to read line. Now, here's the thing. If okay, let's change that. This will be output of type string, and you do line equal read line. Then we do if line is equal to null, then return output, which will break out of the while loop, so we're good. Turn output. Used before being assigned. I can see how. Alright, let's keep going and we'll. This needs to be. There we go. If it isn't, then we output plus equals line. Simple enough. And we need to add because I think we're stripping away the end-line character. Yeah, for sure we are. So we need to add it back up. It's used before being assigned. Well, how's that? That make you happy? There we go. So I wonder if there's a way to instead have this condition in the while loop. Could I do that? Instead I do line does not equal null. A line would need to be here. Let line type string. But the thing is that we update the line inside the while loop. That's my problem here. That doesn't work, right? How would I do that? It's already too late. What if I have it at the bottom? Well, that's a problem too, because we would be. No, I don't see any other way to do it for now, anyways. Right? Seems. Return output. A recursive function, maybe? Nah. Okay, let's just try this, see what happens. Didn't like it. Why? received, no, make string from readline, cannot read property next index of undefined. That's interesting. So the problem is in my string, apparently. My string reads next index. This is the place where it reads it. Why would next index be cannot read property next index of undefined? This would be undefined. How can this be undefined? Yikes, that's interesting. What's it getting? It's getting this. All right, time to debug. Pretty sure the problem's in here. Let's do that. Okay, let's go in. This is undefined. This is now my string. Next index of 0. So, oh, maybe this needs to be set before? We're about to find out, but how did I pass my tests? No, the array's there. That's fine. This is still my string. It returns value of my string with the primitive value of this. That's good. Now we go to that. Okay, you know what? Let's do that. Wait, how did it not pause? Is type error not considered an exception? That seems odd to me. So I guess we will need to have a break line. Breakpoint, I mean. We know that we get to this point here. What's our stack here? Yeah, okay. So this is undefined at this point, which is fine. I guess that's not where the problem happens. Read line. Aha. Yeah. There's a problem. That's interesting. You need to figure this out. Very interesting. Let's run this again. So we get in there. This object, that's the global. Make string from read line. Why would this be undefined? It's very interesting. Could I fix this by simply passing this here? If I do this, I do this. That just screw things up. Let's take a look. No, that didn't change anything. Yikes. Why would you? So I'm passing in the readline function, but like the scope doesn't come along with it. That's what I understand. I thought it would. It should, really. Let's take a look at the JS output. Here. Oh, I would need to look at the JS output of the, and I can't do that, of the test. It's kind of compiling it live from TypeScript. Okay, so what if I was passing the entire string? That's not what we want to do. How about, oh, I think maybe this will work. Const my string no, I don't see why that would change anything, but my string dot readline. See if it does. Nope, same problem. That is weird. That is weird. So if that's not the problem, let's get back to what we had here. For some reason, it's not passing its scope. Let's do this. Let's forget about the export here. Huh. So what if I was trying this here? Trying to do exactly what I'm doing. Oh, my expected. Okay, and I need my implementation of this function. And console.log actual. Let's see, run. Yeah, cannot read properly, length of undefined. Basically the same problem. I believe. See if I can debug this in here. Pause on exceptions. reload this thing. Manually reload. Oh, you can't debug? Really? It needs to be in a separate file. Ugh. That's a bummer. Okay. What do I do with this? What do I do with this? Could spend the next who knows how long trying to figure it out. Or I could just move on and find another way to do this. I am curious though. I don't understand why the scope doesn't come along with the function. Readline is a method on the MyString object class, whatever. So if I'm taking that, why wouldn't it? Very strange to moi. So how could I circumvent this for now? I'm gonna have to do some research to figure this out, but for now, we really just want to get our stuff in here. So let's just comment this out for now, because I will want to come back to this. Now, of course, this test is so problematic. So, alternative. Well, we're just going to use this. This stuff here basically does what we want. Right? If we take all of that stuff, if we do const file equals magic plus I don't want this to, okay, let's do this a little differently. Let file, or let's just call it, yeah, let's call it image file. Image file equals, this is just a string really, yeah, so let's start with this, then go const magic equals do we even need to store this? I don't think so. Image file plus equal readline. Basically, that's all I need to do here. That's very hacky, but I'll get what I want in the end. Nope. I would be wrong. That's not a read file call. So let's delete that. var inputs. So that's a read line. Comments. That's this max intensity, that's another read line right here. Oh, and they also need to have the new line character, I think. Oops. Let's do this. Okay, now. This can all be deleted. We did need the H here though. We'll figure it out. File. How did we get the H? That's from our second read line. Okay, so let's call this inputs did equals that. We're taking this. Taking image file plus equals. Did I delete it or just? Okay, so first we're getting our magic number thing. Don't need this. Right. So I should have 1, 2, 3, 4 read lines before getting into the loop. 1, 2, 3, 4. So I got. Okay, so this should work. And to test that, we'll just do a simple image file. Although this was never my problem. problem was the opposite. Trying to get this. Well, whatever. So let's run this inside. See what we get. Oops. Image file. Okay, this is still working. Unexpected token function on line 1. This shouldn't end up in the... I think maybe it might. What? Oh, okay. I think I've got this hooked up to the wrong file. I do. I've got it hooked up to the TS file. Easy mistake. To correct. There we go. Let's run this. Okay. Good. So that's what we want. Perfect. Nice. So this will do the trick. It's not pretty, but we've got our file now. And now that we have our file, we can just do, what was I trying to do here? Starting to work on my thing. Need to feed it the file. And now I've got my file. Okay. Oh yeah, all of this was so I could test. So I've got a way to get the file into my class. Once I do have the file inside my class, what do I do with it? What information do I need? I need let's see. I need to build a 2D array. I need to build a 2D array of my pixels. That's the one thing I need to do. So a pixel array, basically. So that's what we're going to do. We're going to call this private. Pixel. I'm just going to call it pixels. How's that? Yeah, pixels. Seems good to me for now, anyways. And that's going to be a 2D array of numbers. And this will be constructed here. We're going to take our file, essentially do sup, Rishi? Rishi! If you're just joining us now, I'm working on, hey, thanks for the follow. Working on this cool puzzle from Code and Game, implementing a seam carving algorithm, which is basically an algorithm to reduce image size. So if I am to parse this, I'm using TypeScript. It's a superset of JavaScript. It's basically JavaScript with types and some cool additional stuff. It's similar to C#, I would say, in many ways, or Java, I guess. But it, it transpiles to JavaScript. The typing syntax is a little different, but it's pretty easy to understand if you're used to static typed languages. Okay. So the problem I'm having is I'm trying to solve this puzzle, but I'm also thinking of, building my class in a way that can be used outside the Code and Game environment. So am I going to be parsing the file this way? File needs to be of type string. Okay, then I can do, yep, that'll work. Const my file equals my string, new my string. This is kind of silly. Nah, let's do it this way. File that split. And no, I'm not a full-time streamer. But I try to stream every weekday morning at 9 my time, which is Eastern Daylight Savings Time, Eastern Coast of the United States and Canada, North America. So file.split. This will be file array, I guess, for now. well, I probably don't even need to store this. I just need to go through this. Let's say with a for each loop. So for each line, now here's what we're going to do. Line. We don't care about the first line. Let's take a look at our input again. We don't care about P2. Oh, I'm missing 30 and 8. So I am missing a read line here. Parsing this, inputs. That's what I was missing. Like this. There we go, okay. So, P2. I don't care about P2. This is useful. I need this. Do I? Yeah, I guess I do. So let's get, let's do it this way instead. Start by doing that. Let's sort it. File array. Let's just call it lines because that's really what they are. We're taking the lines. We will store we'll split line 2, so I can probably do this. Const W H equals lines. It's the second one, and I want to split that string with this. Okay. Now that I've got this, I want to, what else do I need? From our input, we need, so we didn't need this, we needed this, we don't need, well, we do here. Yeah, we do here. So third line is going to be called const new size, new width, or required width, no. Target width, how's that? Target width, width equals lines 2. And then we need a for loop. No, we don't care about this one. So starting from 0, 1, 2, 3, starting at index 4, we need our for loop. this here for now. Let's see if we can play with this. So I is going to start at index 4. As long as I is smaller than h. H dot. Basically just parse int. This will work. Parse int. Just do it straight in here. Parse int. Actually, instead of doing this, I can probably just do that. Yep. So what am I doing here? Running through the entire rest of the file for each line. I don't want to do that. Taking lines I, and I'm splitting that for each space, and then for each width. I've got to do something with this here. What do I do with this? I think I prefer calling this line or row. How about that? Row. Let's call it line. We're still in. Okay, and this is where should we simply extract that? Probably should. This would be better if I just did a slice. Right, so let's try that. We're going to call this let's just do lines dot slice. Sweet. Now we're starting at index 4. And once we've got that, we want to map each line, and instead of having a string, which we have now, we want that string to be split. So we're going to call this line, quite simply, return line dot split. There we go. And this is actually our pixels array. Oh yeah, I gotta make those So now we're splitting those. Got to map again. And take each line. And this time, no. Not quite. I'm not going to do that in another map. Line, I turn this line into an array. To do something right here with that array. Going to be mapping that array. So now it's each pixel. It's now going to become parse int. Parse int. Pixel. Okay. Now we're in business. So I don't think we need this. Functional for the win. Okay, we've got this. We're not using our target width yet. I don't need it to... Wait, declares value is never read, not yet. Same thing here, so we're probably going to need to store this. Private target width. There's a type and number. Target width. Parse int. There we go. Okay. Don't even need W and H here. But I might later on. It might be useful. So console.log out for now. Okay, remove seam. We're back to remove seam. What do we need to do first thing in our algorithm? Take a look. Get rid of this. First thing we need to do, we need to compute the seams. No, not yet. We need to oh yeah, energy calculation. That's what we need to do first. It's this part. All of these. Paste that in here for reference. So we need to go through the entire pixels array, and for each pixel assign a value, an energy. Now here's the thing. If we want to be efficient about this, we probably don't want to first go down the entire image array, pixels array, and then assign a value, and then go back up and then start assigning our cumulative energy pathfinding thing. We can probably do all of that at the same time as we're going down. It would probably be more performant if we did it that way, instead of having to iterate through the array several times, is what I'm thinking. Now I'm wondering if I should have a pixel class to store, because we're gonna need to store a few things here. Let's take a look here at this here. We need to store, so each square is going to have 3 pieces of information. One, it's going to have its original grayscale value. 2, it's going to have its individual what would I call this? The gradient hold on, we are calculating the gradient. What were we doing here? Right. I think we are using right, okay. So we're going to need the original grayscale value, which we're not seeing in this graph here. Then we need to calculate basically the total gradient for both directions, x and y's. And then we need to calculate a separate value, which will be the accumulation as we go down. Yep. Yep. I think that's what we're going to do. I think that's what we're going to need to do. So let's do that right away. Export. I might not need to. Just class pixel structure grayscale value. It's a number. Okay, actually I can just do private like that. So then we can start when we're here. We're actually going to start by storing our pixel class objects here, and this will obviously need to be an array of pixel to the array of pixels. Yes, this is a little confusing, so let's do this.
1, 2, 1, 2, 3,
Actually, this can stay here, but instead we'll use brackets here, like that. We're going to be doing this here. Seems more readable, I guess. To return this, there we go. Yep. Okay, so now we've got our array of pixels. What do? We need to go down that array of pixel. Starting the top left. Right. Right. So,
1, 2, 3.
oh, and I'm going to have to go in a few minutes, but let's see if we can start this. So if we're taking our pixel array and we want to use a for each here. This gives us a row of pixels. What do we do with that row? For each row, we need to look at each individual pixel. Okay, so we're going to need more than just a row. We're going to need the index as well. So row index. And now we've got our row. We take a look at the individual pixel. And we do something. Pixel should be of type pixel. That's what, yep, okay. And we'll call this column index. My brackets here, there we go. Okay, so now what do? We've got our pixel. Yay! Well, we need to, oh yeah, we need to do this here, this stuff here. Now here's the fun thing. Do we make this a function on the pixel class itself? We make this a function on the pixel class itself, or do we make it on the PGM image? Well, the pixel by itself is not aware of its neighbors, right? So I would need to pass in information about the neighbors into the pixel class. That doesn't make much sense to me. So it should be on the image. It should be on the image. So let's make a private function that we're going to call, what are we going to call this one? What are we going to call this one? maybe calculate energy. I wonder if I really need to store the... Let's think about this. So I need to calculate this. I need to compute this number. But really, or this here, I mean, but do I need to store it? This 3 here. Do I need to store it? I don't think so. No, I don't think so. Yeah, okay. So we're going to call this calculate energy, I guess. Might reword it later, rename it later. What are we returning? We are returning a number. Simple as that. Okay, how are we going to do this now? What do we need to pass in here? What do we need to pass in here? Well, we need our x and our y, basically. X and y index, right? And this is where I don't want to get confused because our row index, how about we just use that? Row index, column index, how's that? Call it x's, y's, whatever. So now we pass in our row index here, pass in our column index there. What do we do with this? Well, we're looking at our pixels array. And okay, this is what we're doing. First, we have to compute this stuff here. Put it in here. Don't need it here anymore. Okay, well, I guess I'm gonna stop here. I really need to go. This is obviously gonna take me a few sessions to get right. So we'll keep going tomorrow. See you tomorrow, guys.